The digital alembic coding in the world of chemical engineering. Should chemical engineers learn to code? In today's world, this is less of a question and more of a necessity. Like a trusty wrench or a well-worn lab coat, coding has become an essential tool for the modern chemical engineer. Why? Because chemical engineering is no longer confined to beakers and Bunsen burners. It's a world of complex simulations, automated processes, and big data analysis, all of which rely heavily on the power of coding. From designing more efficient solar panels to optimizing drug delivery systems, coding is helping chemical engineers tackle some of the world's most pressing challenges. So, if you're a chemical engineer or aspiring to be one, embracing coding isn't just a good idea, it's essential for staying ahead of the curve. In the following sections, we'll explore exactly how coding is revolutionizing the field of chemical engineering. The virtual chemist, simulating reactions and processes. Imagine predicting a chemical reaction without stepping foot in a lab. That's the power of process simulation, a cornerstone of modern chemical engineering made possible by coding. Using software like Aspen Plus or COMSOL Multiphysics, engineers can create virtual models of chemical processes, from a single reaction in a beaker to a complex industrial plant. These simulations allow engineers to test different scenarios, optimize conditions, and troubleshoot problems, all in a safe, cost-effective digital environment. Coding is the language that brings these simulations to life. The language of control, automating chemical operations. Think about a modern chemical plant. It's a symphony of pumps, valves, sensors, and reactors, all working together to produce a desired product. Controlling this intricate dance of chemical reactions and physical processes is no easy feat, and that's where automation comes in. Coding is at the heart of automation, enabling engineers to program controllers that monitor and adjust process variables in real time. These controllers, often based on programmable logic controllers, PLCs, act as the brains of the operation, constantly collecting data from sensors and making adjustments to keep the process running smoothly and safely. This level of automation, made possible by coding, not only improves efficiency and consistency, but also enhances safety by reducing the risk of human error. Section 4. Python, MATLAB, Simulink, the engineer's coding toolkit. Now that we've seen how coding is used in chemical engineering, you might be wondering, which programming languages are most relevant for this field? 3 stand out: Python, MATLAB, and Simulink. Python, known for its readability and versatility, is excellent for data analysis and visualization, tasks often encountered in chemical engineering research and development. MATLAB excels in numerical computation and algorithm development, making it a natural fit for tasks like modeling chemical kinetics and designing control systems. Simulink, a graphical programming environment that works seamlessly with MATLAB, is ideal for modeling and simulating dynamic systems. By mastering these coding languages, chemical engineers gain a powerful toolkit for tackling a wide range of challenges. Section 5. Coding, a catalyst for career advancement. In today's competitive job market, a degree in chemical engineering is no longer enough. Employers are increasingly seeking candidates with a strong foundation in coding, recognizing its value in driving innovation and efficiency. Whether it's developing process simulations, designing automation systems, or analyzing large data sets, employers are looking for engineers who can leverage the power of coding to solve complex problems and optimize operations. This demand for coding skills translates directly into career advancement opportunities. Engineers who can code are often entrusted with more challenging and rewarding projects, leading to faster career progression and higher earning potential. So while a solid foundation in chemical engineering principles remains essential, complementing it with coding skills is a strategic investment in your career. Section 6. Ready to code? Tips for chemical engineers. Embarking on the coding journey might seem daunting at first, especially for those with limited programming experience. But fear not. With the right approach and resources, anyone can learn to code, regardless of their background. Start with the basics. Familiarize yourself with fundamental programming concepts like variables, data types, loops, and conditional statements. Online platforms like Code Academy, Khan Academy, and Coursera offer excellent introductory courses tailored for beginners. Choose a language and stick with it. As we discussed earlier, Python, MATLAB, and Simulink are particularly relevant for chemical engineers. Pick one that aligns with your interests and career goals and focus on mastering its fundamentals. Practice, practice, practice. Like any skill, coding proficiency comes with practice. Start with small projects and gradually increase the complexity. With dedication and persistence, you'll soon be wielding the power of coding to revolutionize your approach to chemical engineering.